Part of this graphical limit assignment was to do some of your own practice problems. So we have practice problem number 1 here. And I want to take you through those answers. So the limit as x approaches 0. So I'm looking at, as my graph is approaching 0 from the left and from the right, we do want them to be the same thing. My y value is approaching -2. So again, if you want to just practice following that graph using your finger, it's okay that there are jump discontinuities or holes. You're just looking at right around that point at 0. What is that y value? So we have a -2. Now the limit as x approaches -1. We can see that there's a jump discontinuity there. That jump discontinuity means that our left and our right hand limits do not exist, are different. And because those left and right hand limits are different, that means that this limit as x approaches -1, that does not exist. That doesn't exist, but the left hand limit does exist. And that left hand limit, we know we're looking at the left hand limit when we see that little negative in the corner. So coming from the left of our graph, my y value is approaching 2. Even though there's a hole, the y value is still approaching 2. From the right, my y value is approaching 4. Again, it's okay that there's a hole there. My y value is still trending towards 4. G of -1, though, that's when we're looking for the closed circle. We want to know what exactly is the y value that's defined. The y value that's defined happens at -1, 6. The limit as x approaches 4 from the left. So following that graph all the way in from the left, again, ignoring that jump discontinuity, just that behavior right around 4 is headed towards 3. From the right, the behavior is headed towards 5. Therefore, because the left and the right hand limit are not the same, my general limit, just the limit as x approaches 4, that cannot exist unless the left and the right hand limit are the same. So that takes you through number 1 in your practice problems. Number 2 in your practice problems, this is a little bit of a different one. So it starts off pretty normal. The limit as x approaches 3. Essentially, what is your y value headed towards when x is equal to 3? It's okay that there's a hole there. The y value as x approaches 3 is still approaching a +3. Now, what about at -5? -5, I see this vertical asymptote at -5. So coming in, we're actually going to do C and D first. Coming in from the left of -5. As x approaches -5 from the left, you can see that my y values are getting squished down along that vertical asymptote. Because my y values are getting squished down, my y values are getting smaller and smaller and smaller, and therefore headed towards a -infinity. In a similar way, we can look at the limit as x approaches -5 from the right. As we're coming in from the right, my y values are getting squished up against that vertical asymptote, and the y values are getting higher and higher and higher. So therefore headed towards +infinity. Because my left-hand limit is headed towards -infinity, and my right-hand limit is headed towards +infinity, those are not the same numbers or concepts. Those are different, and therefore the limit as x goes to -5 in general cannot exist. All right, question E. We're looking at f of -1. Pretty simple. What is my y value when x equals -1? We have 6. The limit as x approaches -1. As x approaches -1, my y value is 6. The limit as x approaches a +infinity. As x goes towards a +infinity, as x is getting bigger and bigger and bigger, we can see that my y values are getting squished along that horizontal asymptote at y equals -2. So we have -2 as my answer for G. And then in a similar way for H, we have that horizontal asymptote at -2, and that means that my y values are getting super duper close to that y value of -2. And because my y values are approaching that -2, that is my limit.